All right, let's get right into it. We're about to tackle something that, well, most of us probably learned in school and just took as a given. The idea that there's an infinite number of prime numbers. But what if that famous proof isn't quite the slam dunk we've always been told it is? And yeah, that is the huge question we're digging into here. We're going to unpack a really fascinating critique that pokes a hole in one of the most well-known truths in math, and it all comes down to a single, really powerful idea. Okay, that is a bold statement, right? The author we're looking back here doesn't just say there's a minor error. They call the entire proof dubious. They're calling the whole thing into question. So let's break down exactly why. So here's the thing. The argument isn't that someone messed up the math or that there's a calculation error. Nope, it's all about what the proof actually proves. And this is where we get to the core of it, this difference between what we can know versus what actually exists. And this is really where the whole argument clicks into place. The classic proof, you might remember, it gives us a kind of recipe. Take every prime number you know about, multiply them all together, add one, and voila, you can find a new prime. But the author's point is that this just shows a process. It proves we can always find one more. It doesn't prove that an infinite number of them are already out there just waiting for us. So that's the absolute key, is being able to make one more of something. The same thing as proving that an infinite number of them already exist, just floating out there in some mathematical ether. The author here argues, no, those are two very different things. Okay, and this is where things get really interesting, because we're about to step out of the world of pure math and walk right into philosophy. This is the question the author puts on the table, and honestly, it really makes you pause. Think about it. If a number is so theoretical that we can't do anything with it, can't name it, can't even do basic math with it, then in what sense is it even real? Let's put that another way. Does something have to be knowable, at least in theory, for us to say it exists? We've stepped into some deep philosophical water here. But the author suggests that, yeah, when it comes to numbers, being knowable might just be a requirement. So to pull this really abstract idea out of the clouds and make it totally concrete, the author gives us this amazing thought experiment. It's designed to push the whole prime number proof right to its breaking point. Let's talk about the big prime. And yeah, this is a seriously mind-bending concept. We are not talking about a number that's just, really, really long. We're talking about a number so fundamentally massive that you couldn't even write it down if you used every single atom in the universe. There isn't enough physical stuff to contain the information. And bam, right there is the problem. Remember that recipe from the proof? Multiply all the primes you know and add one? Well, you just can't do it. If your known prime is this big prime, a number that can't even be described, the whole process grinds to a halt. It's impossible. So what does it really mean for a number to be unknowable in this way? It means all the things that make a number, they just vanish. You can't identify it. You can't write it. You can't compare it to anything else. You can't even do basic arithmetic with it. It just becomes a void. All right, so now that we have this big prime idea, this wall at the very edge of what's knowable, the author is ready to bring it all home and deliver the final verdict. And the logic is really simple and direct. If something, in this case a number, has zero properties we can identify, and we can't interact with it in any way, shape, or form, then how can we possibly say it exists? According to this line of thinking, we can't. And there you have it, the final, unambiguous conclusion. Because the proof's method completely fails when you hit this theoretical limit, the author argues it doesn't actually prove an infinite number of primes exist. It only shows we have a process that works, but only within the realm of numbers we can actually know. And that's what we're left with, this really big, provocative question. And you can see how this goes way beyond just prime numbers, right? This gets into physics, philosophy, just what is real? What is the true relationship between what we can know and what actually is? It's definitely something to chew on.